In this video, we're looking at rational inequalities. You're going to see that this is going to be similar to polynomial inequalities, and we're actually going to start the same way by setting the inequality to 0. And in this first example, it's already set to 0, so we have to find the zeros just like we did with a polynomial. But here with rational inequalities, we have something divided here. This polynomial is x squared minus 1 divided by x. So once we have this set to 0, we need to first identify the zeros, just like we did with polynomial inequalities. But we also need to define where it is undefined. And you can recall when we talked about rational equations, we're looking at where they were undefined. We have to do the same thing here with inequalities. So to find the zeros, this is pretty simple. Once we have the equation, the inequality set to 0, the only way this is going to go to 0 is if the numerator goes to 0. So if we take x squared minus 1 and we think of setting that equal to 0, then we solve for x. X squared is equal to 1. And if we take the square root, we would get x equals, keep in mind, that would be what? Plus or minus 1. So if x is equal to 1 or negative 1, then this is going to be equal to 0. Now, we also have to determine where is this undefined. Well, that's going to be when the denominator, which is x, is equal to 0. Well, that's easy enough. It's going to be undefined when x is 0. So using the zeros and the numbers where this is undefined, we're going to do just like we did with the polynomial inequalities and identify the test intervals. Now, keep in mind, we're looking at the intervals where we're setting up to find where the graph could change signs, where this inequality is going to change signs from positive to negative or negative to positive. Well, again, that's only going to happen at zeros and at points where the inequality is undefined. So, just like before, we're going to go from negative infinity to negative 1, and then from negative 1 to 0, 0 to 1, and 1 to infinity. So once we have the intervals, we then, just like before, have to find our test values. And again, we're simply picking a number within the interval. So again, I'm going to pick the smallest and easiest number, in this case, negative 2. Negative 1 to 0, I would pick a negative 1/2. 0 to 1, I would simply use 1/2. And from 1 to infinity, I'm going to pick 2. And then we want to test the inequality. So again, we want to plug this into the x squared minus 1 over x. So what happens when we plug this into x squared minus 1 over x? Now again, I'm going to use the calculator. So if we type in, let's see, I'm going to make sure I use parentheses here, x squared minus 1. Close your parentheses because it's the whole x squared minus 1 divided by x. And I'm going to go into the table. And we need to plug in the values negative 2, negative 1/2, 1/2, and positive 2. So I'm going to quickly enter those values in. We have negative 2, negative 1/2, positive 1/2, and a positive 2. So we're getting out negative 1.5, 1.5, negative 1.5, and a positive 1.5. So if I record those values, we get negative 1.5, positive 1.5, a negative 1.5, and a positive 1.5. And just like before, as far as the conclusion, what are we concerned with? Again, we're concerned with, is it positive or negative? Well, here we have a negative. Here we have a positive, negative, and positive. And in order to find our solution, we need to make sure we look at the inequality carefully. Well, x squared minus 1 over x, when is this less than 0? So we're strictly less than 0, so it cannot be equal to 0. It has to be less than 0, which means it's going to be negative, and that's going to occur from negative infinity to negative 1 and from 0 to 1. So that's going to be the intervals. Now keep in mind, are we going to use a bracket on negative 1 and positive 1? Or 0? Well, the answer to that is no, because again, this is strictly less than. So the solution then would simply be negative infinity to negative 1, and then we have our symbol for or. It could be 0 to 1. So this is going to be our solution. And if we look at the solution on a number line, we can label this here as negative 1. We have 0. From negative 1, we're going to the left, and then we put a parentheses on 0, and we're going from 0 to 1, so we would shade in between 0 and 1. So graphically, for the solution, that would be the answer. Now, let's quickly look at the graph of this inequality, x squared minus 1 over x, and see if the graph is below the x-axis within these intervals here. So we can simply go to the calculator. I'm going to go to Zoom Standard again. And if we look, the graph from negative infinity to negative 1, well, negative infinity all the way up here to negative 1, the graph is below the x-axis. And then it looks like we have 0 to 1. Well, from 0, the graph here all the way to 1 is below the x-axis. So all of these values of x would be solutions to this inequality because we're looking at all of the values that are below x. I'm sorry, below the x-axis. So from looking at this, we know then that our answer is correct. Okay, if we look at another example, let's look at the inequality 5 plus 7x divided by 1 plus 2x is less than or equal to 4. Now, to start off, we're going to have to make sure that we set the inequality to 0. So that means we need to move the 4 over. So we would have 5 plus 7x over 1 plus 2x minus 4 is less than or equal to 0. Well, now we want to combine these two terms together. So in order to combine these together, we need to find the least common denominator, which we can understand this to be over 1. So basically we have 1 plus 2x and 1, so the LCD is simply 1 plus 2x. So that means if we were to take 5 plus 7x, that's already containing the LCD, so we leave that alone. But the 4, we need to multiply by 1 plus 2x on the bottom, so that means we need to multiply the top by 1 plus 2x. So if we simplify this, then we have 5 plus 7x. Now, this negative is with the 4. So when I distribute this, I'm going to distribute not just the 4, but I'm distributing the negative and the 4 here. So that's going to give me negative 4 times 1 is negative 4. Negative 4 and 2x is a negative 8x. And this is all over the common denominator 1 plus 2x. So now we simply need to combine the like terms on top. So we would have 5 plus 7x minus 4 minus 8x. So 7x minus 8x would be negative x. And then 5 minus 4 is plus 1 over 1 plus 2x. Now, this is very similar to the first example we looked at. We now have this, if we go back up here to that first example, we have our rational expression here simply to 0, and that's what we have now. We've solved this so that we simply have this rational expression less than or equal to 0. So that means we now need to find the zeros, which means we're going to take the numerator, which is negative x plus 1, set that equal to 0. And if I move the x over, we get 1 equals x, so that means the 0 is x equals 1. And then we need to identify where is this going to be undefined. Well, we're going to take the denominator and set that equal to 0. So 2x is equal to negative 1 divided by 2. We get a negative 1/2. So we have a 0 of 1 and we have x equals a negative 1/2. So now we can use these values to set up our test intervals. And you may want to pause the video and see if you can come up with this on your own, but I will tell you towards the end of this, when we're looking at the actual solution, you need to be very careful with whether you're using parentheses or brackets. All right, hopefully you paused the video and you tried to work this out on your own. Let's set up the intervals. We're going to go from negative infinity up to a negative 1/2, and then from negative 1/2 to 1, and then from 1 to infinity. And then we could identify what are we going to use for our test values. I'm going to use negative 1, 0, and 2. And then we need to test this to find the value of the rational expression. So again, that was using the, up here we need to plug it into this here, negative x plus 1. What happens if we plug this into negative x plus 1 over 1 plus 2x? So if we test this, what do we get out? Well, once again, I'm going to use the calculator to help us here. So if I go to y equals, we can type in our expression, which was a negative, make sure I use parentheses, negative x plus 1, close the parentheses, divided by parentheses 1 plus 2x, close the parentheses. So again, be careful putting this in the calculator and make sure you put in the parentheses here because we want the entire numerator divided by the entire denominator. So then if I go to the table, I'm going to clear out my previous numbers, and we're going to test negative 1, 0, and 2. So I'm going to type in negative 1, 0, and 2, and I get out negative 2, 1, and a negative 0.2. So here we have negative 2, 1, and a negative 0.2. And if you didn't pause the video before, see if you can finish the problem from here to find the conclusion and the solution. So the conclusion is we know that this obviously then is going to be negative, positive, and negative. And how can we determine the solution? Well, we have to make sure we go up and verify the inequality again. We're looking at where this is less than or equal to 0. So if this is less than 0, that means it has to be negative. So we have a negative here from negative infinity to a negative 1/2, and it's negative from the interval 1 to infinity. Now, here's the part we need to be careful with. We know that the solution is negative infinity. All right, let me do that a little bit better here. We know we're going from negative infinity. So we know that infinity has parentheses. We're going to 1/2, and then we're going to look at 1 to infinity, and I know the infinity has parentheses. Now the question is, on the 1/2, do I use parentheses here, or am I going to use a bracket? So we're trying to figure out what happens if I plug 1/2, or I'm sorry, this should be negative 1/2 rather. I forgot the negative here. What happens if we plug in a negative 1/2? Well, if we go up here and we look, this is where we had a negative 1/2. And a negative 1/2 is where this inequality is undefined, because negative 1/2 is going to make the denominator 0. So if the denominator is 0, then it's undefined. So due to the fact that the negative 1/2 is going to make the inequality undefined, that means we have to use parentheses on the negative 1/2. Now, what about the positive 1 over here? Well, what happens at 1? Well, that was one of our zeros. That is simply making the inequality here equal to 0, which means we would have 0 is less than or equal to 0, which means 1 is a solution, so we would enclose that with a bracket. So it'd be negative infinity to negative 1/2, or 1 to infinity. And once again, on a number line, we could identify the solution. We could mark off negative 1/2. That means it's going to be parentheses to the left, and then we mark off 1, which means you would have a bracket going to the right. And once again, we can kind of verify this. If we go to the calculator and simply hit graph, we can see that from negative infinity to what? How far did we go? Negative infinity to negative 1/2. From negative infinity to negative 1/2. And what happens, and it's kind of hard to see, if you notice here, the graph splits. This is negative 1/2 right here, and this graph never gets to the negative 1/2. So that's why we use the parentheses at a negative 1/2. And then it's going to continue then from 1 to infinity. So the graph then from 1 to infinity is below the x-axis. So this graph also verifies that our solution is correct. So hopefully you can see the connection with the polynomial inequalities that we did in the previous several videos, where we were looking at where the polynomial was 0, and we're doing the same thing by looking at when this rational inequality is 0, but we also have to identify when it is undefined. So the extra step here is setting that denominator equal to 0.